In today's video, we're going to focus on graphing other trig functions, specifically the cosecant graph or function, the secant function, and the tangent function. So the cosecant function, as you know, the cosecant is a reciprocal of the sine. So if we think about our sine and our cosecant when we come to a unit circle, and we think about how these points are 1, 0, and the radius is 1, 0, 1, radius 1, negative 1, 0, radius of 1, and we have 0, negative 1, radius of 1. And we know that this represents 0 or 2 pi, right? Pi over 2, pi, and 3 pi over 2. Okay? And so when we think about our sine here, our sine of 0 radians, or 2 pi radians, but our sine of 0 radians is going to be y over r, 0 over 1, or 0. Our cosecant, however, is going to be r over y, which is going to be 1 over 0, which is going to be undefined. When we get to pi over 2, we see that our sine is going to be 1 over 1, or 1, and our cosecant is also going to be 1 over 1, or 1. When we flip it, it's going to be the same. When we get to pi radians, our sine is going to be 0 over 1, which is 0. However, our cosecant is going to be undefined, because when we do 1 over 0, that's undefined. And again, when we get to 3 pi over 2, we're going to have a sine of negative 1 and a cosecant of negative 1. And so if you notice, whenever our sine is 0, our cosecant will be undefined. And when our sine is 1, our cosecant will match it. When our sine is negative 1, our cosecant will match it. And so that'll bring us over to the picture. Now I want you to kind of go to the image, and we're going to translate what that means in our curve. If you notice, this is your basic sine curve. When you're at 0 radians, your sine is 0. When you're at pi over 2, your sine is 1. When you're at pi, it's 0. 3 pi over 2, it's negative 1. And back to 2 pi, it's 0. Our cosecant, however, is represented in blue. And if you notice, what's going to happen here is wherever the sine is 0, notice that we have an asymptote there because our cosecant is undefined. So the first way that you start graphing a cosecant graph is you graph the sine graph, and wherever the sine is 0, the cosecant is going to have an asymptote there because it's going to be undefined. Okay, so again, this is the normal sine wave, and then I'm going to do my cosecant through my asymptote through all the zeros. The second thing you're going to notice we talked about is whenever the sine is 1, the cosecant is 1. So here and here. And how you're going to graph it is you're going to do these parabolas up and away from the x-axis towards those asymptotes, up and away and towards the asymptotes. And when you go to negative 1, the same thing, down and away from the x-axis. So again, the official graph of the cosecant doesn't really include the sine portion of it. So you can actually erase out the sine part and just be left with the part that represents the cosecant graph, which would be your asymptotes and these points and these parabolas. If you leave the original sine graph, I'm totally fine with that as well. So the trick to this is really to graph a proper sine graph, and then the cosecant kind of bounces off of that. So we're going to keep going. We're going to just not worry about the stuff on the right. And now we're going to talk about secant. And so the secant graph is the reciprocal of the cosine graph. So following what we did in the last section, whenever your cosine is 0, your secant is going to be undefined. And so it's the same concept here. You're basically going to graph your cosine graph, which you know starts at 1, then it goes to 0, then it goes to the negative 1, back to the 0, and back up to 1, and that's one full cycle. And then I go the other way, and again, this cosine curve at this point, you should have it pretty much memorized. And then what you're going to do is your secant curve, well, wherever your cosine is 0, you're going to insert this asymptote through all the zeros. So that would be, after you graph the cosine, you focus on the asymptotes. And then wherever you have a high point, your 1 or whatever, you're going to go up and away towards the asymptote and create your parabolas. And so you just keep doing it like that. These points are included. And remember, the secant and the cosecant had a range. Remember, they were secant and cosecant were always either 1 and greater than 1 or -1 and less than -1. There was never, we talked about the fact that the range did not include the values between 1 and -1. That was reserved for sine and cosine. And so this makes sense. You might wonder, why am I cutting it off here at the edges? Like, why am I not doing a full parabola there? Well, remember that we want you to graph 2 periods. And so from -2 pi to 0, this is 1 period. And then if we go over to 2 pi, that's 2 period. And so we're sort of cutting it off. So yes, this should have, another part to it, obviously. But again, we're stopping it so we don't have to see that portion. We're just going to ask you to graph 2 full periods, which would end here. So now let's actually graph it and see it in practice. So we come over to here and we start out with our basic 2 secant of half x. So what we're going to do here is we're going to notice that our a is 2. So I know that our amplitude is going to be the absolute value of 2 or 2. I know that my b is a half. And so my period is going to be 2 pi over the half. So my period is going to be 4 pi. And, I should have started by saying we know that this 2 secant half x, we're going to start by graphing the cosine version of that because the reciprocal is the cosine. So where I'm getting, all these values too is because I'm thinking about 2 cosine of half x. Okay, so that's kind of where I'm getting these values, just like we've done before. So I come to my graph and I'm going to focus on graphing that. So I know, again, my period is 4 pi, so I do 4 tick marks and I get to 4 pi. I do 4 quarters basically, and I get to -4 pi on the left, and each tick mark is a quarter of 4 pi. So a quarter of 4 pi is pi, here and here. A half of 4 pi equals 2 pi, so here and here. And 3/4 of 4 pi is going to be 3 pi. And so this is my last quarter there, and -3 pi. So I know my cosine graph, again, my amplitude is 2. And so if I'm just graphing, to be consistent, let me do it in red. The basic cosine graph of this, y equals this, I know is going to start up at 2. Second point is at 0. Third point is at -2. Fourth is here, and then back up. And so my basic curve looks like this. And I do the same thing on the other side. Again, this part of it, guys, at this point should be really easy to graph this basic cosine graph. Now, what I'm going to do from here is I'm going to graph my secant graph. And so I know that everywhere where I go through the x-axis at 0, right, wherever the value, the y is 0, I'm going to put an asymptote. So I'm going to put an asymptote through -3 pi, through -pi, through pi, and through +3 pi. So there's my asymptote, and then I'm going to draw my graph off of the peaks and the lows. So since this was a high here at 1, I'm going to graph it this way. Down here, I'm going to go down and away from the x-axis. Here, I'm going to go up and away. From here, I'm going to go down and away. And from here, I'm going to go up towards the asymptote. And again, I'm not going to the left or I'm not going to the right because I'm stopping at exactly the 2 periods. So if you want to keep the red in there, that is totally acceptable. If you want to highlight, if you want to highlight the cosecant part of it to show me, or the secant part of it to show me that that's what you want, that's fine. Again, I'm not going to get involved in you know exactly how you do it. If you want to erase out the cosine part, I totally am okay with that, just to clean it up. At the end of the day, what's in purple in this drawing is exactly what you need, okay? You need what's in purple, and you also need to make sure that you give me these values here, okay? These values on the x-axis are super important. I need those in my graph. You know, I need the amplitude, the high and the low, and then everything that's in purple, the asymptotes and the graph. The original cosine graph is not necessary, but that's it. So here I see that I have a cosecant graph. Now this one's a little bit more challenging in my opinion. If you look at this one has a reflection over the x-axis and it has a phase shift. Okay, so this one's a little bit more challenging, but still doable. So we know that this is the reciprocal of the sine. So I'm going to do minus sine of x minus pi. And so I know that my a value is -1, which means my amplitude is going to be the absolute value of -1 or 1. And I also know because it's a -1 or a negative, I know it's a reflection over the x-axis. Okay, so it's kind of important there. Remember when we do a phase shift, we told you we weren't going to change the period. And so notice the b value is 1, so our period is still going to be the basic 2 pi. And lastly, our entire graph is going to shift pi to the right. So this is going to require a little bit. So I'm going to focus all my energy right now on graphing this sine graph, okay? So when I come to my graph, I don't have to do anything drastic. I know my graph usually starts pi over 2, pi, 3 pi over 2, and 2 pi, right? If I'm shifting pi units to the right, I know my graph is going to end up, this is 5 pi over 2, and this would be 3 pi. My graph is going to end, instead of ending at 2 pi like it normally does, my sine graph, it's going to end at 3 pi. Because again, that's 1 pi over to the right. So I'm going to draw this, I'm going to kind of draw the point all the way to 3 pi because I know I'm going to shift that way. On the left side, I have negative pi over 2, and I have negative pi. And even though I'm adding in negative 3 pi over 2 and negative 2 pi, I know they're not going to be utilized on my graph. Because again, remember, my graph normally ends here, right? And now it's really going to end here because that's pi units to the right. So if I'm legitimately shifting everything pi, I'm not going to be using the negative 3 pi over 2 or the negative 2 pi portion of the graph. So anyway, but let's see how I would graph this, right? So I know my first point, well, my altitude or my amplitude is going to be 1, and it's going to be -1. So I know that instead of my first point being at 0, 0, it's going to be at pi, okay? And I know that I'm going to move over pi over 2 units for every point. So at 3 pi over 2, normally I would be up here. At 2 pi, I'd be here. At 5 pi over 2, I'd be here. And at 3 pi, I would be here. And my wave would look something like this. However, we have to remember this reflection over the x-axis. So while my zeros are going to remain the same, my zeros are going to be in the same spot, my y values are going to be opposite, right? So I know that here 3 pi over 2 is going to go down and 5 pi over 2 is going to go up because again this was a reflected graph, okay? And so that's one period towards the right, and then the other one is going to go in the opposite direction. So obviously pi over 2 units I'll go here. At 0 I'll be there. At negative pi over 2 I'll be here, and I'll end it at negative pi. And again, this is the graph. And so this is the reflected version of the sine of x minus pi. So now that I have my sine graph and I know my sine graph is done, now I'm ready to do the rest of this, right? I'm going to erase this out. I don't need that, right? But now I'm going to focus on graphing the actual cosecant part of this graph. So the cosecant part, remember, wherever their x or wherever the y is 0, that's going to get an asymptote in it. So I know that my cosecant will be undefined at these values. So I just keep doing my things. Sorry, I'm kind of going into my writing. And then again, where you have a low point, you go down and away. High point, you go up and over. Low point, down and away. And here, up and away as well. And now there you have your graph. So yes, your graph kind of shifted into there, but the purple asymptotes and the purple graph is the graph of this cosecant. Like we've talked about, the red is not necessary. It's just our guide. You can erase it or keep it. I'm okay with that. But this is really what we need here. Okay, so everything in purple is the graph of the cosecant. Now we're going to go towards our tangent curve, and tangent's a little trickier because tangent has a smaller period, first of all, and it just looks a lot different. So the basic period of a tangent is pi radians. So basically, and it also looks like a cubic function, if you notice, right? You're going to have a point through 0, you're going to have, you're going to go up and you're going to go down, and this is the basic tangent function. So each one of these, you have an asymptote, you have the curve, and you have another asymptote. And if you notice, your asymptotes are exactly pi units apart, okay? And so you are going to be graphing these, and all you have to do is graph 2 of these, okay? Because again, we're just graphing 2 cycles. What some people do when you're graphing, and we're going to talk about the values and stuff, but sometimes what they do is the first one straddles the y-axis. So in other words, we know this is pi units apart, but it's half pi this way and half pi that way. And so they do, you know, here's one cycle with your 2 asymptotes, and then at this point, you can either choose to do one more full cycle, so you would basically just graph these 2 functions that are in yellow, these 2 cycles or periods that are in yellow, okay? What I've seen done a lot, and I know this is how the other teachers teach it, is they actually make it symmetrical to the y-axis. So what they sort of do is they do this half of the period, basically this whole period, right? This is one period. And then they do half of the period to the left, and they do half of the period to the right. Okay, and so it looks kind of weird because when they graph it, what you end up having is, you know, you have one full one here, you have a half one on this side, and you have a half one on this side, and they kind of don't do any of this other stuff, okay? And so for me, I don't know that I love it that way, but again, if you want to make your window 2 cycles, you could make your window this portion of it, because that is 2 cycles. It's 1 whole and 2 halves. Or again, you could do 2 to the right or 2 to the left. And so again, it's really up to you how you want to do it. I don't think I'm going to have a preference, so I'll kind of show you on the graph. But all right, so how do we come up with our values? How do we come up with our periods? How do we come up with our things, right? Well, the amplitude's going to be the same. The absolute value of A is still going to be the amplitude, and the amplitude is going to show up here. It's going to be represented by those values here, like 1 and -1. So it's still important. You're still going to have your 0 values, okay? So you're going to have a 0 value. Your 0 value is going to be smack dab in the middle of the 2 asymptotes. And your amplitude, your high and your low, is going to be halfway between the center and the other asymptote, okay? And so it's going to be, you know, interesting. So when you look at this and you say, okay, well, how did these values come up? How did they get these? Let's think about that. If basically we have our period is pi, what they did was they straddled the x-axis. They went half pi units this way, and they went pi over 2 units this way. So they went to pi over 2, and they went to negative pi over 2. And if I break that in half, if I figure out, well, what's half of pi over 2? That's pi over 4. So this is pi over 4, and this is negative pi over 4. And so on the right, it goes up, and on the left, it goes down. And that's exactly how you would graph these. So if you notice, basically across all, we're still going to have our 4 tick marks. And how you do it basically is, now that you've figured out that this is pi over 4 units every tick mark is pi over 4 units away. So pi over 4, 2 pi over 4, which simplifies to pi over 2, 3 pi over 4, 4 pi over 4, which again simplifies to pi, 5 pi over 4, 6 pi over 4, which simplifies to 3 over 2. And that's how we get this, okay? So we'll do some, but again, we'll work on how to find those values because, again, you are going to have to label them, okay? If for whatever reason this is a reflected graph, the reflected graph would go up on the left and down on the right, just like a reflective cubic graph. So that would be a reflection of it over the x-axis. That's what that would look like. So I'm going to skip this graph. You can read this for yourself and try it, but I'm just going to walk you through setting it up and doing it. So right here we have y equals 2 tangent of 4x. So again, we've got to focus on graphing this. Let's understand what we're going to do. We're not going to shift it up. We're not going to shift it to the right or left in tangents. Okay, with tangents, all we're going to do is basically change the amplitude on you and potentially change the period. So in this problem, a is 2, which means the amplitude, again, is the absolute value of 2 or 2. We know that b equals 4. Now the period here, remember that the basic period of a tangent function is pi. So the period is pi over b. So this is a little bit different. So the period's going to be pi over 4. So I'm going to kind of come over here and I'm going to figure out where do my asymptotes go, where does everything go. So if my period is pi over 2, I want to know what half of pi over 2 is. I'm going to do pi over 2, or pi over 4 rather, and I'm going to take half of it. And I see that that's pi over 8. That means that I'm going to go pi over 8 to the right, and I'm going to go pi over 8 to the left. Remember that between pi over 8 and negative pi over 8 is 1 period, which is what we've got here, okay? And then remember that we know that we have to find the midpoint of those as well. So the midpoint of pi over 8 is half of pi over 8, or pi over 16. So this is pi over 16, and this is negative pi over 16. Now, at this point, we know now then that what we can do is we can graph our first point, which is here at 0, 0. We know that we're going to go up to, our amplitude is 2, right? So up to 2 and down to negative 2. We know we're going to go up to 2 on the right, and we're going to go down to negative 2 on the left. And we know that these are going to be our asymptotes. And so this is how we create our first period. I should have started with the asymptotes, but that's okay. And then again, I know my curve is going to go this way. Sorry, terrible curve. And it's going to look something like that. Okay, let me make this curve a little prettier because honestly this is a terrible curve, but it's, you know, kind of has to look curve-like, right? Sorry, it's terrible. Anyway, but that's how you do it. And so those are your critical values. And so I can decide now, how do I want to do my next period? Well, I know everything's going up now by pi over 16. So this is like 2 pi over 16, which simplifies to pi over 8. This would be 3 pi over 16. This would be 4 pi over 16. This would be 5 pi over 16. And this would be 6 pi over 16. Now, I know this simplifies to pi over 4. And I know this one simplifies to 3 pi over 8. Okay? Either way, it's the same thing. It's pi over 16 over. I know that if I wanted to just go one full period to the right, I would end up with an asymptote through this one. I know that in the middle of those two asymptotes would be my 0. On this right, the 5 pi over 16, that's where the 2 would be. And at 3 pi over 16, that's where I would go down. And again, I would have a whole nother cycle of my thing. And that's 2 pi. That's 2 periods of pi. And that would be a good graph. If you wanted to go to the left, you could do the same thing. Again, it's negative. I'm going minus pi over 16 every time. So this would be minus 3 pi over 16, minus 4 pi over 16, minus 5 pi over 16, and minus 6 pi over 16. And again, I know that this would be my asymptote here. In the middle of that would be my 0. In the middle of the 4 pi over 16 and negative pi over 8, right, I would have my 2. And in the middle of the other one, I would have my negative 2. And again, I could do another one. So if you notice here now, I've done 3 periods. This is 1 period, this is the 2nd period, this is the 3rd period. Again, they only want 2, so I could either choose to do the 2 on the left, I could choose the 2 on the right, or I could even do like they did, like I told you the other teachers like to do. I could erase here. Let me see if I can get my eraser. I could erase this left side here, and I could erase out this left side here. And basically what I would be doing is I would be doing 1 period here in the middle, I would be doing half of a period there, and I would be doing half of a period there. And that is completely acceptable. So think of it as like a window that kind of breaks right here, which is super messy, and sorry about that. But you could do that as well. So again, however you choose to do it, I would learn to do it either way in case we ask you on a test to do it one particular way over another. But again, I would just know how to do it both ways, all right? But basically that's the gist of it. So now let's try this last one. This one's a little bit trickier because this one has a reflection. So again, we already talked about what a reflection would look like. Instead of going up on the left and down or going up on the right and down on the left, you're going to go up on the left and down on the right. So again, our A value is -3, which means our amplitude is the absolute value of -3, which is 3. Our period, because again, a basic period in a tangent function is pi, then our period's going to be pi over b, so pi over 1/2, so our period's going to be 2 pi. And we're going to have a reflection over the x-axis, which means our graph is going to look like that, okay? So again, let's just try to figure out where our asymptotes are going to be, and let's try to figure out how we're going to graph this. So if our period is 2 pi, then I know that I'm going to go pi units to the left, and I'm going to go negative pi units to the right, because together, right, negative pi and pi add up to 2 pi. Now I have to figure out what this midpoint is here, so I have to figure out what is half of pi, or pi over 2. So I know that this is pi over 2 units to the right, and this one's pi over 2 to the left. So for this first one, I know that my first period is going to have an asymptote here at pi, another asymptote here at, or negative pi and pi. My center is going to be 0. Now I know my points, my 3 and my -3, are going to be at pi over 2 and negative pi over 2. But because there's a reflection here, I know that I'm going to have to go up on the left this time and down on the right. And so it's going to be up this way and down this way. And so I've just done 1 period. Now at this point, I have to do a 2nd period. So if I wanted to just do those half periods that we talk about, you know, half to the right and half to the left, I know my units that I'm going up are pi over 2. So pi over 2, pi, that's 2 pi over 2, 3 pi over 2, and 4 pi over 2, which is 2 pi. So I could go there. I know that this would be my 0, and I know that at this one is where my 3 pi over 2 would be, and I would go like that. And I could do the same thing to the other side. I could do -3 pi over 2, -2 pi, and again, I know that's where my 0 lies, and I know the right side would look like that. And I would stop there. I wouldn't have to do the left because, again, here I have pi units, here I go over pi units, and together it's 4 pi, which is 2 cycles. So you could do it that way. And again, if you don't feel comfortable doing the halves, I still think you should learn how to do them. But if you wanted, you could have just as easily gone here to 5 pi over 2 and 3 pi. And you could have done the other asymptote, and you know the graph would be down here, and you'd, you know, kind of go like that. And I know that's a terrible graph, but something like that. So again, if you wanted to do the two periods completely, that's fine too. We definitely like the first period to straddle this y-axis, half on the left, half on the right, and then figure out the rest from there. But that's how we graph tangent.